Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper Math P3 Variant 1 October-November 2021. Let's get started. From the list, write down the square root of 289. The square root of 289 is 17. Write down a factor of 81. 27 is a factor of 81. Write down a common multiple of 3 and 5. 30 is a common multiple of 3 and 5. A, B, and C are three consecutive whole numbers. A is a prime number, B is a cube number, C is a square number. A plus B plus C is less than 40. Find A, B, and C. Since the sum of A, B, and C is less than 40, we know that we can get the values of A, B, and C by listing the first few prime numbers, cube numbers, and square numbers. From the list we see that the consecutive numbers are 7, 8, and 9. So A is 7, B is 8, and C is 9. Put one pair of brackets into each of these calculations to make them correct. For this equation, to make the expression on the left-hand side equal to 20, we put a pair of brackets around 3 plus 7, which is 10. So 4 times 10 divided by 2 is 20. For this equation, to make the expression on the left-hand side equal to 19, we put a pair of brackets around 51 minus 12, which is 39. So 39 divided by 3 plus 6 is 19. Write down the reciprocal of 8. The reciprocal of any number is 1 over the number. So in this case, that would be 1 over 8. Write down the value of 14 raised to the power 0. Any number raised to the power 0 is 1, so 14 raised to the power 0 is 1. Calculate 5 raised to the power 4. When we type this into the calculator, we get 625. Calculate cube root of 6,859. When we type this into the calculator, we get 19. Calculate 16 raised to the power negative 1 over 2. When we type this into the calculator, we get 0.25. In 1 year, a theater sells 496,050 tickets. Write this number in figures. This is the number in figures. To confirm this, you can type 496,000 plus 50 into your calculator. The theater is used for performances of operas, plays, concerts, and musicals. The pie chart shows information about the number of each type of performance. Complete these statements. The type of performance shown the most is blank. Using a protractor, when we measure the sector angle for musicals, we get 135 degrees. When we subtract the sum of 135 degrees, 27 degrees, and 90 degrees from 360 degrees, we get the sector angle for concerts to be 108 degrees. Musicals has the largest sector angle, and so the type of performance shown the most is musicals. The sector angle for this type of performance is blank degrees. We found this angle to be 135 degrees. Write down the percentage of performances that are plays. This percentage is equal to the sector angle for plays, which is 90 degrees divided by 360 degrees times 100%. This gives us 25%. The theater is used for 320 performances in the year. Calculate the number of opera performances. This would be the sector angle for operas, which is 27 degrees divided by 360 degrees times 320. This gives us 24. The number of concert performances is in the ratio classical music is to popular music equals 7:5. There are 56 classical music concerts. Find the number of popular music concerts. First, we set up the ratio. From here, when we cross multiply and make x the subject, this is what we have, which is equal to 40. The table shows the prices of a child ticket and a senior ticket for a play. Alex buys tickets for 2 adults, 3 children, and 1 senior. He pays a total of $159.50. Complete the table. Let's represent the cost of an adult ticket with x. This means 2 times x plus 3 times $15.50 plus 1 times $35 equals $159.50. 3 times $15.50 plus 1 times $35 is $81.50. When we subtract $81.50 from both sides, this is what we have. When we divide both sides by 2, we get x equals $39. Last week, the cost of a ticket for a musical was $65. This week, the same ticket costs $55.90. Find the percentage reduction in the cost of these tickets. The percentage reduction is equal to the reduction, which is 65 minus $55.90 divided by the initial cost, which is $65 times 100%. When we type this into the calculator, we get 14%. 360 people go on a school trip to one of 4 places. Some of the information is shown in the table. Complete the table. When we subtract the sum of 163 and 37 from 360, we get this value to be 160. When we subtract the sum of 65, 12 and 36 from 160, we get this value to be 47. When we subtract the sum of 47 and 62 from 121, we get this value to be 12. When we subtract the sum of 15, 3 and 12 from 37, we get this value to be 7. When we subtract the sum of 36 and 7 from 71, we get this value to be 28. When we subtract the sum of 9, 62 and 28 from 163, we get this value to be 64. Find the probability that a girl picked at random visits the wildlife center. This probability is equal to the number of girls who visited the wildlife center, which is 62, divided by the total number of girls, which is 163. Find the probability that a person picked at random from those visiting the botanic gardens is a girl. This probability is equal to the number of girls who visited the botanic gardens, which is 9, divided by the total number of people who visited the botanic gardens, which is 24. 9 over 24 can be simplified to get 3 over 8. Find the probability that a person picked at random visits the adventure park or the botanic gardens. The probability that a random person picked visited the adventure park is equal to the number of people who visited the adventure park, which is 144, divided by the total number of people, which is 360. The probability that a random person picked visited the Botanic Gardens is equal to the number of people who visited the Botanic Gardens, which is 24, divided by the total number of people, which is 360. The all becomes plus. When we type this into the calculator, we have 7/15. The people who visit the adventure park travel by coach. Each coach has 52 seats for passengers. Complete this statement. The least number of coaches needed for the trip to the adventure park is blank, and there will be a total of blank empty seats. To get the number of coaches needed, we divide 144, which is the number of people going to Adventure Park, by 52. This gives us 2.769. This means a minimum of 3 coaches would be needed. To get the number of empty seats, we subtract 144 from the total number of seats, which is 3 times 52. This gives us 12. The school hires one coach from each of 2 different companies for the trip to Red Castle. A coach from Fast Track Coaches costs $600 plus $0.72 per kilometer traveled. The total cost in dollars for traveling X kilometers is $600 plus 0.72x. A coach from Rapid Coaches costs $550 plus $1.12 per kilometer traveled. Write an expression for the total cost in dollars for traveling X kilometers. The total cost in this case would be 550 plus 1.12x. Both companies charge the same amount for the trip. Write down an equation and solve it to find the distance traveled. If both companies charged the same amount, then the total cost for the Fast Track Coaches, which is 600 plus 0.72x, should be equal to the total cost for Rapid Coaches, which is 550 plus 1.12x. When we group like terms, we get 50 equals 0.4x. When we divide both sides by 0.4, we have x equals 125. The length L kilometers of the journey to the Wildlife Center is 53 kilometers, correct to the nearest kilometer. Complete this statement about the value of L. Since we are correcting the length to the nearest kilometer, we have 53 kilometers, then we bring in plus and minus 1 kilometer divided by 2. The lower bound for L would be 53 minus 1/2 kilometers, which is 52.5 kilometers. And for the upper bound, we have 53 plus 1/2 kilometers, which is 53.5 kilometers. So we have L is greater than and equal to 52.5 and less than 53.5. Samira takes $31.50 to spend in the Botanic Gardens. She spends 2/7 of this money on food. Work out how much Samira spends on food. To get the amount she spends on food, we simply multiply 2/7 by $31.50, which is equal to $9. At the end of the visit to the Botanic Gardens, Samira has $4.50 left. What fraction of her money does Samira spend? Give your answer in its simplest form. To get the fraction of the money she spends, we divide the amount of money she spent, which is $31.50 minus $4.50 divided by $31.50. When we type this into the calculator, we get 6/7. The diagram shows 2 pairs of parallel lines. Find the value of A. If we focus on this pair of parallel lines and the transversal, we see that these 2 angles are alternate angles. Alternate angles are equal, so A is 48 degrees. Find the value of B. If we focus on this pair of parallel lines and the transversal, we see that these angles are corresponding angles. Corresponding angles are equal. Angles on a straight line add up to 180 degrees. So B plus 48 degrees should be equal to 180 degrees. When we subtract 48 from both sides, we get 132 degrees. The diagram shows a quadrilateral ABCD and a straight line ADE. Work out the value of x. The sum of interior angles in a quadrilateral is 360 degrees. So to get this angle, we subtract the sum of 119, 63 and 72 from 360 degrees, which is equal to 106 degrees. Angles on a straight line add up to 180 degrees. So we have x plus 106 degrees equals 180 degrees. When we subtract 106 from both sides, we get 74 degrees. A, B, and C are points on the circle center O. AC is a diameter of the circle and ABD is a straight line. DCE is the tangent to the circle at C. Write down the mathematical name for the line BC. BC is a chord. A chord is simply any line that connects two points on the circumference of a circle. Explain why angle ABC is 90 degrees. This is because the angle formed in a semicircle is 90 degrees. Find the value of x. Base angles in an isosceles triangle are equal. So to get this angle, we subtract 2 times 46 degrees from 180 degrees, which is equal to 88 degrees. Angles on a straight line add up to 180 degrees. So we have x plus 88 degrees equals 180 degrees. When we subtract 88 from both sides, we get 92 degrees. Find the value of y. If this angle is 90 degrees, then this angle would also be 90 degrees. Based on the alternate segment theorem, these two angles should be equal. All the angles in triangle BCD should add up to 180 degrees. So we have y plus 90 degrees plus 46 degrees equals 180 degrees. When we make y the subject, we have y equals 44 degrees. 11 students record the time they spent on social media and watching television during 1 week. The table shows the time in hours for each student. Find the range of the times spent on social media. The range is simply the highest value minus the lowest value. The highest time spent on social media is 28 hours and the lowest time spent on social media is 2 hours. 28 hours minus 2 hours is 26 hours. Complete the scatter diagram. The first 9 points have been plotted for you. So on the grid, we plot the points 19.511 and 1120. What type of correlation is shown on the scatter diagram? On the grid, we see that as the number of hours spent on social media increases, there is a general decrease in the number of hours spent watching television. This implies a negative correlation. Draw a line of best fit on the scatter diagram. The general rule of thumb for drawing a line of best fit is to ensure the line passes through as many points as possible while balancing an equal number of points above and below the line. Another student spends 21 hours watching television. Use your line of best fit to estimate the number of hours this student spent on social media. The vertical axis represents the number of hours spent watching television. So when we map 21 from the vertical axis to the line of best fit, we get the estimated time for social media to be 11.5 hours. The diagram shows the travel graph of a train journey from Wengen to Kleiner Scheidegg. Explain what happens between 14:09 and 14:10. We see that between these two times, the train stopped or waited at Wengenalp. Find the journey time from Almond to Wengenalp in minutes. To get the journey time, we simply subtract the departure time from Almond, which is 13:59, from the arrival time in Wengenalp, which is 14:09. Under the minutes column, we can't subtract 59 from 9, so we get 1 hour from the hour column, which becomes 60 minutes under the minutes column. So now we have 69. 69 minus 59 is 10. In the hour column, 13 minus 13 is 0. So the journey time is 10 minutes. Calculate the average speed for the train journey from Wengen to Kleiner Scheidegg. Give your answer in kilometers per hour. The average speed would be equal to the total distance traveled divided by the time duration between the 2 points. From the grid, we get the distance from Wengen to Kleiner Scheidegg to be 6.4 kilometers. To get the time duration, we subtract the departure time from Wengen, which is 13:54, from the arrival time in Kleiner Scheidegg, which is 14:19. Under the minutes column, we can't subtract 54 from 19, so we get 1 hour from the hour column, which becomes 60 minutes under the minutes column. So now we have 79. 79 minus 54 is 25. Under the hour column, 13 minus 13 is 0, so the time duration is 25 minutes. To convert 25 minutes to hours, we divide by 60. When we type this into the calculator, we get 15.36 kilometers per hour. Another train travels from Kleiner Scheidegg to Wengen. The table gives information about its journey. On the travel graph, draw the journey for this train. So on the grid, we mark the departure time from Kleiner Scheidegg, which is 14:01. From Kleiner Scheidegg, the train arrives at Almond at 14:18. Then it leaves Almond at 14:20 and arrives at Wengen at 14:30. After marking these points, we draw straight lines connecting the points. Write down the time when the two trains pass each other. On the grid, we see that the trains pass each other at 14:09. The temperature in Wengen at 5 a.m. is -3 degrees Celsius. At 4 p.m., the temperature has increased by 10 degrees Celsius. Work out the temperature at 4 p.m. To get the temperature at 4 p.m., we add 10 degrees Celsius to -3 degrees Celsius. This gives us 7 degrees Celsius. A formula to work out the temperature at different heights above Wengen is T equals 2 minus h over 130, where T is the temperature in degrees Celsius and h is the height in meters above Wengen. Kleiner Scheidegg is 780 meters above Wengen. Work out the temperature at Kleiner Scheidegg. All we need to do is plug in h equals 780 into the given formula. This gives us -4 degrees Celsius. The diagram shows the net of a cuboid on a 1 cm squared grid. The net is folded to form the cuboid. Write down which two corners join to corner A. Imagine we try to close the given cuboid. We see that point C joins to point A. Then we also have point G, which comes to join point A. Write down the edge which joins with KL. If we imagine closing the cuboid, we see that HI connects with KL. Find the total surface area of the cuboid. On the diagram, we found the surface area of each of the faces of the cuboid. So for the total surface area, we have 2 times 20 centimeters squared plus 2 times 10 centimeters squared plus 2 times 8 centimeters squared. When we type this into the calculator, we get 76 centimeters squared. Find the volume of the cuboid. On the diagram, we get the length, width and height of the cuboid as 5 centimeters, 4 centimeters and 2 centimeters. So the volume would be 5 times 4 times 2 centimeters cubed, which is equal to 40 centimeters cubed. The diagram shows a cylinder with length L centimeters. The radius of the cylinder is 3.2 centimeters and the volume is 775 centimeters cubed. Calculate the value of L. The volume of a cylinder is pi r squared h. In this case, h is L. When we make L the subject, we get V over pi r squared. V is 775 centimeters cubed and R is 3.2 centimeters. When we type this into the calculator, we get 24.1 centimeters rounded to 3 significant figures. Calculate the volume of a solid sphere with radius 3 centimeters. We know the volume of a sphere is 4 over 3 pi r cubed. In this case, R has been given as 3 centimeters. When we type this into the calculator, we get 113 centimeters cubed rounded to 3 significant figures. 4 of these spheres are placed inside the cylinder. Calculate the percentage of the cylinder that is empty. This percentage is equal to the volume of the cylinder, which is 775 centimeters cubed, minus the volume of the 4 spheres, which is 4 times 113 centimeters cubed, divided by the volume of the cylinder times 100%. When we type this into the calculator, we get 41.7% rounded to 3 significant figures. The diagram shows a right-angled triangle ABC. Show that BC equals 75 meters. To get the length of BC, we apply the Pythagoras theorem. This gives us AB squared equals AC squared plus BC squared. When we make BC the subject, we get square root of AB squared minus AC squared. AB is 125 meters and AC is 100 meters. When we type this into the calculator, we get 75 meters. Calculate angle BAC. To get angle BAC, we apply SOHCAHTOA. This gives us cos of angle BAC equals 100 meters divided by 125 meters. When we make angle BAC the subject, we have cos inverse of 100 over 125. When we type this into the calculator, we get 36.9 degrees rounded to 1 decimal place. The diagram shows a shape made from 2 right-angled triangles. The total area of this shape is 246 centimeters squared. Work out the value of x. The total area of the shape is equal to the area of the 2 triangles, which we have labeled as A1 and A2. We've been given the total area to be 246. A1 is half of its base, which is 16, times its height, which is 12. A2 is half of its base, which is 20, times its height, which is x. Half times 16 times 12 is 96, and half times 20x is 10x. When we group like terms, we get 10x equals 150. When we divide both sides by 10, we get x equals 15. On the grid, draw the image of triangle A after a rotation of 90 degrees clockwise about the origin. First, we need to mark the center of rotation, which is the origin. Then we rotate each vertex on triangle A 90 degrees in the clockwise direction about the origin. This means if, let's say, we pick point A, we draw a line from point A to the origin. Then we measure and mark 90 degrees in the clockwise direction from this line. From here, we draw a line from the origin, passing through the 90-degree mark. The final step is to now mark the new position of point A on this line such that the distance from this new position to the origin is the same as the distance from the origin to the original position of point A. After repeating the same process for all the vertices on triangle A, we are now able to map out the rotated image of triangle A. Draw the image of triangle A after a reflection in the line x equals 5. So first, we draw the line of reflection, which is x equals 5. From here, we need to reflect the vertices of triangle A in the line x equals 5. So for point A on the triangle, since we move 2 units to the right to touch the line of reflection, we also need to move 2 units to the right from the line of reflection to pin the new position of point A. We need to repeat the same process for points B and C on the triangle as well. When we are done, we are able to map out the reflected image of triangle A. Draw the image of triangle A after an enlargement, scale factor 2, center 7, 7. First, we need to mark the center of enlargement. Then we need to move each vertex on triangle A such that we are able to reproduce the enlarged image of the triangle. Let's pick point B. To move from the center of enlargement to point B, we move 4 units to the left and 2 units downwards. And so to pin the new position of point B, we move in the same direction due to the positive scale factor. Since the scale factor is 2, we move twice the number we moved initially. Initially, we moved 4 units to the left, which means we are now going to move 8 units to the left. And instead of moving 2 units downwards, we move 4 units downwards. After repeating the same process for all the vertices on triangle A, we are now able to map out the enlarged image of triangle A. Describe fully the single transformation that maps triangle A onto triangle B. When we look at both triangles A and B, we can tell straight away that this is a translation because both triangles have exactly the same size and orientation. The only thing is that they are located on different parts of the grid. So now all we need to do is find the translation vector. From the illustration, we see that each vertex on triangle A has moved 7 units to the left and 2 units upwards. This means the translation vector is -7, 2. And so the full description for the transformation would be translation by the vector -7, 2. Complete the table of values for y equals 4 plus 3x minus x squared. When we plug in x equals -2 into the equation, we have y equals -6. For x equals 1, we get y equals 6. And for x equals 3, we have y equals 4. On the grid, draw the graph of y equals 4 plus 3x minus x squared for x is greater than and equal to -2 and less than and equal to 4. So on the grid, We plot all the points in the table and connect the points with a smooth line. The line y equals 2x minus 1 is drawn on the grid. Use your graph to solve the equation 4 plus 3x minus x squared equals 2x minus 1. To solve this equation, all we need to do is find the x-coordinate of the intersection points of the curve and the line. This gives us x equals negative 1.8 and x equals 2.8. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.